Hello, this video is going to be a start for probability. Now you're going to see a lot of symbols here, ways to write things, and I'm going to focus mainly on gaming probability, basic gaming probability. Now you have this thing called events. Event is just when you're doing something. Draw one card, roll a single die. Those are events. And you have this thing called a sample space, which is the capital letter S, which is your total possible outcomes. The probability of something is always equal, of a basic probability is equal to the number of outcomes in the event divided by the total number of outcomes in the sample space. Now, whenever you're doing probability, you should always write these bottom up. I know you're probably wanting to read from left to right, top to bottom, but when determining probabilities, always do bottom up. Never do the other way around because it can throw you off for things we're going to get into soon enough. Now, the way to write probability of something is like this. You have a capital P, and then inside grouping symbols, whatever you are doing as your event. Some basic probability rules are probabilities are always between or including 0 and 1. The closer to 0 something is, the less likely something will happen. The closer something is to 1, the more likely it will happen. The probability of every single thing happening should always add up to give you 1. 0 is probability of something not happening. 1 is the probability of something happening. Now, most probabilities we're going to do, I'm going to want you to write as simplified fractions. Please do not give any decimals unless you are given decimals. Now, you do have this thing called a complement of an event. And the way you write that is you put a bar over whatever it's asking for. Now, I emphasize the word usually because this is not always, but usually when you're asked to find probability of at least something, that is a red flag going up saying do the complement or find the complement. And the way to do that is you do 1 minus, for the actual calculation, it's 1 minus the probability of what it asks for happening. Now, a couple other rules you have here is you have what's called the addition rule of probability. The probability of something or something else, and right there I made an association. When you see this big U, which is called a union, that refers to the word or. So probability of one thing or another thing is equal to probability of the first plus probability of the second minus the probability of the first and the second happening at the exact same moment in time. So when you see this upside down U, that is called an intersection or a symbol for intersection and refers to the word and. The multiplication rule, probability of one thing and another. You take probability first, probability second, and just multiply those two together. So I'm going to start off here with probability of drawing cards. And in your books, I believe it's section 4.1, or wherever you would find probability first mentioned, you'll usually find a picture like this one. And this is called the sample space for choosing a card or sample space for what's called a standard deck. There are two colors, red and black, and there are 4 suits, top to bottom. We have hearts, diamonds, spade, and clubs. Then you have 3 face cards. Face card always and only refers to Jack, Queen, and Kings, which means non-face cards are 10s through aces. Aces are essentially here going to be considered a 1 card. Now, how many cards does this incorporate total? This is 52 cards in total. So now let's find some probabilities. So we have first the probability of a club. And it says drawing a card, which means a single card. So first, always figure out what is the sample space of this. So the sample space of this, how many cards are there possible? There are 52. So now then, out of those 52 cards, how many are clubs? Well, there are 13. And then you simplify that, which would give you 1/4. This is the probability of a red 5. Again, bottom up. First, what's the sample space? How many things are you working with total here? You're drawing cards from a standard deck, and standard means no jokers. That's essentially what it refers to. So that means there are 52 cards. Out of those 52, what am I looking for? A red 5. How many red 5s are there? There are 2 of them. And then you simplify that, which would give you 1 out of 26. Now you might notice the way I'm writing these fractions. I'm writing them with horizontal bars. Please always write fractions with horizontal bars. Do not write any fractions with slashes, please. Because if you have this, this might look like 1/2 and then a 6. So if you write them this way, any and everybody will be okay with it. But no slashes, please. If you do use slashes for this, it is likely you might lose credit. Okay, there we go. So now this says I want the probability of a red 5 or a diamond. Okay. So this is going to become the probability of a red 5 or means plus the probability of a diamond. But I have to make sure to subtract a possible intersection. So make sure to subtract the probability of a red card being a red 5 and a diamond. Now, it is likely when some of this subtraction of overlap you might do, it might not ever be possible. And that's okay. Now, if I had 3 things that I was wanting probability of this or that or a third, well, then I'd have to subtract the probability of 2 of them happening at the same time in every combination, and then the probability of all 3 happening at the exact same time. And what you're doing there is you're taking away the opportunity of a double count. So first, probability of red 5. How many do you have to work with? Well, you have 52 cards. Out of those 52, how many are red 5s? 2. Still have 52 cards. Now you have to remember this said or, so you're essentially doing this all over again. So out of the 52 cards, how many are diamonds? 13. Now what's the probability of a red 5 and a diamond? So is there a card that's a red 5 and also a diamond? If so, how many are there? That does happen. It exists. Here's your red 5 that's also a diamond. That's 1 out of 52. Because out of 52, there's only one of those. And the reason you're subtracting this is because here's a red 5. Technically, with the diamonds, there's the second red 5 being counted again. So this essentially is saying there's 2, 3 red 5s, but that is not entirely true, and that's the purpose of subtracting this intersection. So now you just do the math. 15 minus 1, so that would be what? 14 out of 52. And it's okay to just punch all this straight in your calculator at once. That would just give you 7 out of 26. Okay, so now this guy. I want the probability of a 6 and a spade. So this becomes now the probability of a 6 times probability of a spade. So the probability of a 6 is what I need to calculate first. Well, how many cards are there? 52. Out of those 52, how many are 6s? There are 4. Now, this alone, probability of a spade, there are 52 spades. Or, I'm sorry, there's 52 cards, but out of those 52 cards, how many are spades? 13. Now, if you need to, rewind back and pay attention to how I just did that. I first figured this out alone, and wrote those two results. Now I'm going to do some calculation with it. Try not to let this confuse you into thinking, well, you took one out, so there's one fewer. It's just that you're drawing one card, so that's not an issue. So you can just go on ahead and punch this straight into your calculator. You have 4 out of 52 being multiplied by 13 out of 52. And that would just give you 1 out of 52. Now here it says I want the probability of a diamond or a red card. Okay. So first probability diamond, or means plus, probability red card, but then I have to subtract a possible overlap. So first probability of a diamond, how many cards are there? 52. Now 52, how many are diamonds? 13. And then I have a plus. How many cards are there? There are 52. And out of the 52, how many are reds? Out of the reds, there are 26. Now I have 52 cards. Now those 52, how many are diamonds and red? That'd be 13. There are 13 which are both a diamond and a red card. Yeah, that might sound like a redundant thing, but that's just what you have. We're right here, these are all red cards and they're also diamonds. Do the math here and you'll end up with 1/2. Now next we have the probability of a black face card and a 7. So first I'll rewrite this. Probability of a black face card. And that'll be multiplied with the probability of a 7. How many cards are there? There are 52. And out of 52, how many are black face cards? Remember, face cards are only those with literal names. Jacks, queens, kings. No others. There are 6 black face cards. And you have 52 cards. Out of 52, how many are 7s? There are 4 of them. Punch this into your calculator. you'll end up with 3 out of 338. So now for dice. Find a probability of rolling a pair of dice. Dice always refers to more than one. Die refers to one single. And you might read or hear fair die, and what that means is that there is an equal probability of all 6 numbers appearing. And generally that's all we're going to be focused on are just a basic 6-sided die. Now what this picture represents and how it's read is this is the first die and this is the second die. So you could get a 1 on the first roll, 1 on this for the second guy, 1 for the first one, 2 for the second one, 1 for the first one, 3 for the second one, and so on and so forth. The total combinations you have are 36, which means your basic sample space will be 36. So you have 2 fair die rolled, and I first want to find the probability of a sum that is smaller than 6. Alright, so what's my sample space? How many outcomes are possible? There are 36. Out of those 36, how many of those have a sum when you add the 2 numbers, you get a result smaller than 6? Start counting. So this would be one of them because this gives you 2. That's a 3. That's a 3. This will be a 4. 4, 4. 5, 5, 5, 5. Well, this is a 6, but 6 is not smaller than 6, so it is ignored. Which means this diagonal and everything else down here is not counted. So let's see how many you selected or have been selected. And these are different because, again, maybe think of it as colors. And I think when I was Googling to find this type of image, I found one image which had both literal die but in different colors. And that's how you have to think of this. Maybe one die is regular white and another die is like a blue and yellow. But here we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 out of the 36 happening. And then you can simplify this to get 5 out of 18. Okay? Now for a sum that is greater than or equal to 6. Okay? And what this is read as, greater than or equal, is at least. So this is saying I want a sum of at least 6. Well, if we look at the picture, that's everything from this diagonal all the way down, which seems to be a little bit more than what we just counted. And now when you see the phrase at least, I said that usually means do the complement. Well, here's what the complement would look like. 1 minus the probability of not this happening. So instead of a sum that's greater than or equal to 6, what would be the other direction? Well, that would be the probability of a sum less than 6. Well, you already figured that out, and yeah, I did this on purpose. But I wanted to help show you how to interpret one probability into becoming a complement. So I'll have 1 minus the probability of this, which was 5 out of 18. It's okay to use that result. And now I'm going to show you how to do some fundamental math of this. When you have 1 minus some fraction, you'll have a denominator, which is your denominator you see. Now what you're going to do is you're going to do denominator minus numerator. And that goes on top, and there's your answer. Yeah, there's a few or some details which I glossed over, which is back from intermediate algebra or prior math courses to that, but that's a quick way to evaluate a complement without having to punch 1 minus into a calculator. Because usually it'll be pretty easy for you to say, okay, this minus that, there you go. And put that over your regular denominator. Now this says I want the probability of 8 or even, and by 8 that refers to the sum. Yeah, I know there's no 8 on a 6-sided die, but that's what it's referring to. So whatever you would see here, that number would, like 5, here 8, 9, 10, that means the sum being 10, sum being 9, sum being 8. So this means I need the probability of 8 plus the probability of an even, and then minus, because it's or, probability of an 8 and being even. So probability of an 8, how many outcomes are there? There are 36. Out of those 36 outcomes, how many add to give you 8s? 6 plus 2 is 8, 5 plus 3, 4 plus 4, 3, 5, 2, 6. And yeah, this usually happens in a diagonal when you're looking for a sum equaling a specific number. So that's 1, 2, 3, 4, 5. So that would be 5 out of 36. Now, when it says even, that refers to the sum being an even. So this will give you an even, 1 plus 1. Nope. Yes. 3 plus 1 is even, 2 plus 2, that's essentially the same thing as 3 plus 1. This diagonal are odds because that's a 5. This diagonal are good because it's a 6. This diagonal is bad because they're 7s. This diagonal here is good because it's an 8. Bad diagonal, good diagonal, bad, and good. You notice how it sort of went on, off, good, bad, good, bad. Yeah, that would happen. So now we need to count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And this should be 18, because 18 out of 36 is 1/2. And yeah, this should happen to where half the numbers are odd, half of them are even. Now, since I'm rolling 2 fair die, my denominator would still be 36. By 36, I'm looking for the sum equaling 8, and that's an even sum. So let's find out how many that is. So sums being 8, right here. So this is going to give me an 8. That's an 8, that's an 8, that's an 8, that's an 8. So that's 1, 2, 3, 4, 5. Okay? Do the math, and you're going to get 1/2. Yeah, I pretty much just subtracted exactly what I found at the beginning, and sometimes that happens. This is more about getting you to start grasping the concept of finding a basic probability. Now here you have a 5 on one die or on both dice. Okay, so first probability 5 on one die plus 5 on both, and then I'll have to subtract the probability 5 on one and 5 on both. And yeah, I'm just going ahead and I'm writing in the 36 for denominator. Why? Because I'm rolling 2 dice. The total amount of outcomes when you roll 2 fair die is always 36 when doing basic probability. So start off with a 5 on one die. Okay, so I don't care which die it is, I need a 5 on one of them. Here we're good, so 1, 2, 3, 4, 5, 6. Here we're good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I did count 11 because 1, 2, 3, 4, 5, 6, 7, skip 8, 9, 10, 11. Why did I skip it? Because I already wrote that one down. I already have 5, 5. But 5, 4, 4, 5, those are different. 5 on the first, 4 on the first. They're not the exact same. Going this way, 5 on the first, 5 on the second. Going this way, 5 on the first, 5 on the second. That's the exact same. Now I need 5 on both. Out of 36 outcomes, that only happens one time. Now what I need is a die that has a 5 on one of these and a 5 on both. Okay. So I need a 5 on one of these and also having 5 on both. Well, that would be right here. But that's 5 on both. Is that 5 on one of them? I do have a 5 on one of them, and I do have also 5 on both of these guys, so yeah, that counts. So this would just give you 11 out of 36. Now I need the probability of an 8, a 9, or a 10. And when you see it listed like this, if you see or here, that means an 8 or a 9 or a 10 is what that would represent. And I'm going to give myself a little more space here. So that will become the probability of an 8, probability of a 9, probability of a 10, and start subtracting overlaps, which would be 8 and a 9, 8 and a 10, and then I need a 9 and a 10. I have a 10 and an 8. I have a 10 and a 9. I would not do 10 and 10 because I need two different. So then I would also have then all 3. Okay, so these are all the probabilities I'm going to need to find. So they'll all be out of 36. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I have all ready to go. So out of 36, how many sums of 8 are there? I think I already did that. I did. Found 5 of them. And you'll have this happen where you might find something in one question, but then another question later on, they'll ask you part of that again. 9s, I don't think I've done that. So this will start off as a 9. So 1, 2, 3, 4. Okay, so there are 4 to add to give you 9. How many 10s? I know I have 5, 5. And this is the diagonal of 10s. There are 3 of them. Okay. Now this says a sum that's an 8 and a 9 at the same time. Are there any rules you can do where you have the sum being 8 and also 9 at the same time? No. That's a 0. What about an 8 and a 10 at the same time? That doesn't happen. 9 and 10 at the same moment? Nope. 8, 9, and a 10 all adding to give you the same. All of these at the exact same time? Yeah, that won't happen either. And it's fine if you just subtract 0, but still just get in the mode of when you see or, subtract, overlap, subtract, overlap. That way, you're never going to have to worry about, did I forget to do it here? Do I have to do it there or not here? Just go ahead and always do it. So you add all these up. What's this going to give me? That looks like a 12 out of 36. And 12 out of 36 is going to give you 1/3. Okay, so now number 12. Sum bigger than 8. Not done yet. I think it said or less than 5. So this would be the probability of the sum bigger than 8 plus probability sum smaller than 5 minus probability of both at the same time. So there are 36 plus 36 minus out of 36. So out of 36, how many sums bigger than 8 were there? I feel like I did that somewhere. No, it's bigger than 6. Okay. Okay, so sums bigger than 8. 4, 4. So this diagonal are my 8s. How many bigger than 8s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How many smaller than 5s are there? Okay. Find something that adds to give you 5 right here. This is now my 5 diagonal, but I want smaller. So 1, 2, 3, 4, 5, 6. Now, are there any where the sum is bigger than 8? So like these guys. And at the same time, are these also smaller than 5? No. So that means there's no overlap, and that's okay. So when you add these, that's going to give you 16 out of 36, which is just 4/9. Okay, if you have any questions, feel free to contact me, and we'll see you in the next one.